The integration by algebraic substitution is a method of technique in evaluating an integral, which means that when a given integral is not integrable directly, meaning by means of the basic pattern or basic integral, so this is a method that you can use. Algebraic substitution means that you can use any variable or any letter to replace the given integral. So the hint here is that when a given integral has a radical expression and it is not integrable directly. Like for example, in this example number 1, the given is an integral of x, square root of x plus 1 dx. So obviously, this is not integrable by power integral because there is an excess of x here. For number 2 is also the same thing, wherein the given is a radical form and then there is an exact variable x. For number 3 is also similar to that. It is only a reciprocal of number 2. And for number 4, again, it is not integrable by basic integration because there are two radical form or radical expression given here. So the idea is that using or applying algebraic substitution, we will replace the radical form or radical expression into any variable. Now, like for example, in this solution, I replace the radical form, the square root of x plus 1, by the variable y. And then if I'm going to replace this radical form by variable y, so obviously, it's not integrable because they are not of the same variable anymore. So what are we going to do is, we have to replace the excess variable x here in terms of y and the dx in terms of dy. So, since we set that y is equal to the square root of x plus 1, then the next thing to do is we have to look for the value of variable x here. So, algebraically, we can raise both sides by square in order to remove the radical symbol here. So, it becomes y squared and this is equal to x plus 1. Then, you can solve for the x now. So, x now is equal to y squared minus 1 because you can transpose the y on the other side, so it becomes negative. Then after getting the x, you can now find the derivative of x. So finding the derivative of x, this is simply 2y dy. Then the next thing to do is we have to substitute to the given integral. So what will happen? To replace the x here, the value of x is y squared minus 1. So this is the value of the x. And then for the square root of x plus 1, this is simply equal to y. And then for the dx, this is simply equal to 2y dy. And then simplifying, we can multiply the y by y, and that will be y squared. Multiplied by y squared, again, this is y to the fourth, and then y squared multiplied by negative 1, negative y squared. And then for the numerical value of 2, you can express as the coefficient of the integral. And then this time, this is now integrable by power integral. So y to the fourth dy, just simply add to the exponent or to the power and then divided by the exponent plus 1. So this is now 4 plus 1 and that will be 5 divided by 5 or just simply 1/5 y to the 5th. Similarly, the y squared now, the y squared dy now is just simply y cubed over 3 or just simply 1/3 y cubed, and then upon integration plus c. Now, since the given is a variable x, so we have to go back again to the replacement wherein we have that the value of y is square root of x plus 1. So all we have to do is just replace the variable y by square root of x plus 1, and then this is now raised to the 5th. And then on the other term, this is also y, so replaced by square root of x plus 1, but this time this is raised to the cube. So this is now our integral for the integral of x, square root of x plus 1 dx equal to 2 times the quantity of 1/5 square root of x plus 1 to the 5th minus 1/3 square root of x plus 1 to the cube plus c.